Okay, this is a video to do with quadratic graphs and being able to draw an appropriate line, which is a common style of exam question. Now, in order to do this, you need to have a reasonable understanding of drawing quadratic graphs and drawing linear lines with a gradient in the form of y equals mx plus c. So if you're not sure about those, I would suggest you go back and watch one of the other videos that we have available to you. A little bit of background first before we have a look at exam questions as to why this method actually works. So this is for higher GCSE, and it is one of the trickier topics. We are talking up at A and A star to pick up all the maximum marks within exam questions like this. But before we start, we're going to have a look at a simple quadratic graph. So y equals x squared. And I'm just going to do a rough sketch. So you should already know that this is a parabola, a nice curved, smooth and symmetrical graph which comes down to the origin and then back up. So it's nice and symmetrical, although mine is a little bit wonky. So we have the curve y equals x squared. But suppose I wanted to solve this, then I could see that it's actually got a point of intersection where it crosses the x-axis, or in this case just touches the x-axis, coming in from the left, coming in from the right, right at the origin. So we've actually got two solutions, although it's the same value twice. We're going to now have a look at a similar quadratic, y equals x squared minus 1. So this bit tells me that my graph has been translated down the way by 1. So I'm going to draw another sketch. For this time, the y-intercept, because x is 0, the whole bit will disappear. So the y-intercept is 0, so I'm now going to cross at 1. So my curve comes up, nice and symmetrical, and it's shifted down. So now my graph intersects at 1 and negative 1. Because we can factorise the quadratic above, x squared minus 1 is the same as x minus 1, x plus 1, or difference of squares. So from each bracket I can get x equals 1 and x equals minus 1 when I solve and set each bracket equal to 0. So we're going to see how this relates to something which I already have drawn. So I've been asked to solve this one. I want to see how it compares to my original quadratic y equals x squared. So I'm going to have a look at splitting this into two separate parts, because I want to make it look like I already have my y equals x squared. So if I've got x squared minus 1 equals 0, which is I was asked to solve over here, I'm going to rearrange that to get x squared equals 1. And now we're going to have a look at drawing y equals x squared, which I already have above, and y equals 1, and I'm going to draw y equals 1 on the graph and see how it compares to what I have over here. I'll just zoom out just a touch so we can get both of these in. So obviously in the exam you will do it nice and neater. This is just a bit of background before we get started. So y equals 1 is a horizontal line which crosses at 1, but when y is 1, x is also 1, but it could be negative 1. So I actually get the same solution for where my line and my curve cross here as I did when I solved this quadratic crossing the x-axis to start off with. So we can see that we've got a different rearrangement. Two curves, when I put them together and where they meet, can be the same solution as a rearrangement of the two things to give us one curve. So that's the principle behind the quadratic graph work that we're about to have a look at. I'm going to do just another example just to see if we can get that to click in a little bit more. So this time I'm going to have a look at using y equals x squared. We're going to stick with that one just now. But to solve y equals x squared minus x. And in order to do that, I'll need to draw an appropriate line. So y equals x squared. Again, our nice smooth quadratic curve crosses at the origin. And I'm going to have a look at how I can make this curve look like what I have over here and decide what I need to draw in order to solve this one when I've already got this one. So x squared minus x, if I want to solve that, I need to set it equal to 0. I'm going to solve it first of all with our algebra so I know what my graph should, the solutions I should get from my graph. So I'm going to factorise it. I get x times, because I've got x in both parts. It's not into two brackets because I don't have a constant on at the end, but I do have an x times an x here, and I've got a negative 1x here. So x times x gives me my x squared, so I need x minus 1 to multiply out to give me my negative x. So this gives me a solution taking each part of the multiplication to 0. X is 0 and x is positive 1. So it's an easy example to start off with, but just to give us the idea, because we will be looking at some harder quadratics. So I know what my solution is, but I need to be able to get it from the graph which I already have drawn, which is y equals x squared. So I'm going to split my x squared minus x equals 0 into two curves, or two functions. So I'm going to have x squared equals x. I've just taken my negative x and added x to both sides. So I now can draw y equals x squared, which I already have, and y equals x. So y equals x is a line with a gradient of 1, and it has an intercept of 0 because we've got nothing on at the end. So I'm going to go to my graph now, and I'm going to draw y equals x. So it goes through the origin, and it's 1 across and 1 up. So I have a line, gradient 1, so it's y equals x. This is y equals x squared. And that coordinate there is 1, and I have 0. So my curve and my line intersect at x is 0 and x is 1, which is the same solution as I have to the quadratic which I've been asked to solve, but using my y equals x squared. So that's a bit of background as to why it works. Now going to have a look at some typical exam questions to have a look at the wording and the information that we're given. Okay, so here we have a fairly typical exam question. The grid shows on the graph y equals x squared, add 2x, take away 5. So it's already plotted for us. And we have a bit of space underneath where it says, by drawing an appropriate straight line, solve the equation x squared plus 2x minus 5, but that is equal to something else on the other side. So we have this x minus 1. I'll zoom back in so we can see what we've got. So first thing we need to have a look at is, what do we already have in terms of the quadratic drawn, and what else do we still need to draw? So this is the quadratic which is already drawn. We already know this. It's already on our graph. So I need to draw this line here. So I'm going to draw the line y equals x minus 1. So we have an intercept of -1 and a gradient of +1. So y equals x minus 1 we need to draw on our graph, and where those two meet, that is the solution to what we have been asked to work out. So y equals x minus 1. Now, one thing examiners love to do is give you different scales on your graph, so you need to be careful with this. We have this in this example. So you look on our x-axis, we go from 0 and 10 units across, or 10 boxes across, we have 1. But on the y-axis, when we go 10 boxes down, we have a unit of 2. So our scales are slightly out of sync with each other, so we need to be very aware of that when we come to drawing our graph. So we need to draw the line y equals x minus 1. So it has an intercept of -1, which is there, and it has a gradient of 1, so it's 1 unit across and 1 unit up. And then from there we can carry on 1 unit across, 1 unit up. Once we've got a couple of coordinates, we can join in and extend the line right across. So that now is the line y equals x minus 1. And what we're looking for now, because we want to solve the quadratic equation, is where the line and the quadratic we've already got given to us, we've already got drawn, intersect with the x-axis. We want the coordinate of where they intersect, the x-coordinate. So, for accuracy, it'd be useful if you can use a ruler to make sure we're very clear on where we are on our scale. So it's about there. And on the other side, they intersect there. So now I can read off values on my x-axis to give me the point of intersection, which is the solution of where my curve and my line meet. So on the x-axis, I'll have a look at this one first. Well, that's -2, it's -3, so it's slightly more than halfway between the two. So on my graph, for my solution, my value of x is -2.6 from my graph. Now you will be allowed a tolerance in the exam, but you will need to make sure you read it accurately from your graph. On the positive side, I have a value of almost 1.6. So we've got the two solutions of where the line that we have drawn and the curve intersect. And we've just been asked for the x coordinates. And that's worth 3 marks in total. Typical exam question. Let's have a look at the next one. Okay, so we've got a table of values in this one for a quadratic, so it needs to be plotted. And then the second part of the question, 2 marks for drawing it, second mark is 2 marks for solving it. So this is a slightly more straightforward question to start off with, because this quadratic that we need to solve at the bottom is the same as the quadratic that we've been given at the top that we have been asked to plot. So we need the coordinates -4, 2, -3, -2, -2, -4, -1.5, -4.25. So -1.5, -4.25, so that's about halfway, that's about a quarter of the way. -1, -4, 0, -2, 1, 2, and the last coordinate we've been given to plot is 2, 8. So that's purely reading the values from the table that we've been given at the top of the question. So what we need to do now is join those up, and in the exam you're supposed to do your graphs in pencil. So we need a nice smooth quadratic curve. So with quadratics I find it easier if I almost feather it out a little bit first to decide exactly how I'm going to join them up, and then I can make any amendments and go over it a little bolder once I'm happy I have them joined up. I also find it easier to turn my graph slightly to the side and then join it up nice and smoothly. So we're looking for to pick up all the marks so it's a nice, smooth, joined up quadratic graph. So part B we've got in the question now. It says use the graph to find the solutions of where the curve, this is the one we've already drawn, the table above, equals 0. So that is asking for where does it have a y coordinate of 0, which in other words is where it crosses the x-axis. When it crosses the x-axis, we can see we've got 1 point here and 1 point here. So it's about negative 3.6 and about 0.6. From where it crosses the x-axis. Part B for the question, by drawing a linear line on the same axis, find the solution for the equation x squared minus 3 equals 0. So it's different to what we already have. So I'm going to make a note of what we already know. We have drawn y equals x squared plus 3x minus 2. That's what we've already got plotted, what we've already got drawn. But we need to do something in order to solve this x squared minus 3. So I need to look at how this is different, and it will give me the line that I need to draw on top of this in order to solve this one. So I know I need to draw a line, and I'm going to look at what I know minus what I need. This is what I've been asked to solve. So I know what I already have plotted is x squared add 3x minus 2, and I need, and I'm going to be careful with my signs here, I need to solve x squared minus 3 instead. So x squared take away x squared cancels. I have positive 3x and no other 3x is there. There's no other x in this part at all, so that doesn't change. And I have negative 2 take away negative 3. So a negative take away a negative becomes a plus, and I end up with negative 2 plus 3, which is plus 1. So I need to draw the line y equals 3x plus 1. And where my line and my curve cross, I want the x coordinates. I'm just going to abbreviate that, x coordinates. So I'm going to flip back to the graph, and we're going to draw on the graph that we've already got drawn y equals 3x plus 1. So I need to draw y equals 3x plus 1. So intercept of 1 and a gradient of 3. And again, we need to be careful with the scales. So it's 1 box across or 1 unit across and 3 up. So once I have 2 coordinates, I can join those up, extend it along, and you should find that it crosses twice on your curve. And then we're into reading off the values where our curve and our line meet. And again, if any doubt, use your ruler to line it up. So that's about negative 0.8. 1.8, sorry. And on the positive side, I have a value over here, and I make it on my graph from my quadratic 1.6 from my graph. Again, you will need to make sure you read your graph and your line accurately. There will be a tolerance allowed in the exam mark scheme. Okay, so a bit of a summary, a bit of a tip and hints on how to remember to draw the graphs for questions like these. By drawing the appropriate linear line, the line you need to draw is your known or your given quadratic, take away the one that you need to solve. You work out the difference between these, you will get your appropriate linear line, which you need to plot on top of the curve, which you should already have, and then read off values. Hope that helps.